Welcome. Thank you for joining us today. Let's start with some basic questions about your background and experience. Can you tell us about your educational background and how it has prepared you for a career in mechanical design engineering?
Certainly. I have a bachelor's degree in mechanical engineering. During my studies, I focused on courses related to design principles, mechanics, and materials science, which provided me with a solid foundation for this role. Additionally, I've pursued internships where I gained practical experience in applying these concepts to real-world projects.
Can you walk us through a complex mechanical design project you've worked on in the past? What were the challenges you faced and how did you overcome them?
Certainly. One project that comes to mind is test rig, where I was tasked with designing a test rig. One of the main challenges was components and material selection, such as ensuring compatibility with existing systems or optimizing the design for cost effectiveness. To overcome this, I used the simulation approach, which ultimately led to a functional test rig.
How do you stay updated with the latest advancements and trends in mechanical design engineering?
I make a concerted effort to stay informed through a variety of channels, including industry publications, online forums, and professional networking events. Additionally, I regularly attend conferences and webinars to learn about emerging technologies and best practices in the field. Continuous learning and professional development are essential for staying ahead in this rapidly evolving industry.
Communication and collaboration are vital in a team-based environment. Can you provide an example of a time when you effectively communicated a complex technical concept to a non-technical audience?
Certainly. In a previous role, I was leading a cross-functional team that included members from engineering, marketing, and sales departments. When discussing the technical aspects of a new product design, I recognized the importance of conveying the information in a clear and understandable manner. I used visual aids such as diagrams and simplified explanations to ensure that everyone was on the same page, which facilitated productive discussions and alignment towards our goals.
Thank you for sharing your insights and experiences with us today. We appreciate your time and will be in touch regarding the next steps in the interview process.
Thank you for the opportunity. I look forward to the possibility of contributing to your team.
Welcome. Let's start with some questions about your experience with Creo. Can you explain your experience with Creo and how you've used it in your previous roles?
Certainly. I have extensive experience with Creo, having used it for over 5 years in various mechanical design projects. I've used Creo for 3D modeling, assembly design, sheet metal design, and drafting.
What are some key features of Creo that you find most useful for mechanical design projects?
Some key features of Creo that I find particularly useful are its parametric modeling capabilities, robust assembly management tools, and advanced surfacing capabilities. Additionally, the ability to perform finite element analysis within Creo is invaluable for ensuring design integrity.
How proficient are you with Creo's parametric modeling capabilities, and can you provide an example of how you've used them in a project?
I am highly proficient in Creo's parametric modeling capabilities, which allow for the creation of intelligent, feature-based models. For example, in a previous project, I used parametric modeling to create a family of parts with varying dimensions, enabling quick design iterations and customization options.
Have you worked with large assemblies in Creo, and if so, how do you manage performance and organization?
Yes, I have experience working with large assemblies in Creo. To manage performance and organization, I utilize techniques such as simplified representations, component suppression, and top-down design methodologies. Additionally, leveraging Creo's assembly structure and naming conventions helps maintain clarity and organization within the assembly.
Can you discuss your experience with Creo's simulation capabilities, such as finite element analysis?
Certainly. I have utilized Creo's simulation capabilities extensively for performing structural, thermal, and modal analyses. This includes setting up simulation studies, applying loads and constraints, interpreting results, and iterating designs based on simulation findings. Creo's integration of simulation within the CAD environment streamlines the design validation process and ensures optimal product performance.
How do you stay updated with the latest features and advancements in Creo?
To stay updated with the latest features and advancements in Creo, I regularly participate in training programs, attend webinars, and explore online resources such as forums and user communities. Additionally, I make use of Creo's official documentation and release notes to familiarize myself with new functionalities and enhancements.
Can you provide an example of a challenging design problem you've solved using Creo, and how you approached it?
Certainly. In a recent project, I encountered a challenging design problem involving the optimization of a complex mechanism for weight reduction without sacrificing performance. I approached this by utilizing Creo's advanced surfacing tools to create lightweight yet structurally robust components. Additionally, I performed iterative simulations within Creo to validate the design changes and ensure optimal performance.
How do you collaborate with other team members when working on projects in Creo?
Collaboration is key in any design project, and in Creo, I facilitate this by utilizing its built-in collaboration tools such as shared design sessions and model check-in, check-out functionality. Additionally, I maintain clear communication with team members through regular meetings, file sharing platforms, and version control systems to ensure everyone is aligned and working towards the project goals.
What are the key considerations when designing plastic components for manufacturability?
When designing plastic components, it's crucial to consider factors like draft angles, wall thickness, parting lines, and gating locations to ensure ease of manufacturing and minimize defects such as sink marks and warpage.
How do you choose the appropriate plastic material for a specific application?
Selecting the right plastic material involves evaluating factors like mechanical properties, chemical resistance, thermal stability, and cost. Understanding the application requirements and environmental conditions helps in determining the most suitable material.
Can you explain the importance of mold flow analysis in plastic design engineering?
Mold flow analysis simulates the flow of molten plastic within the mold cavity, helping to predict and optimize factors like fill time, pressure, and cooling rate. It allows us to identify potential defects early in the design phase and optimize the mold design for better part quality and manufacturability.
What are some common challenges faced in plastic injection molding, and how do you address them?
Common challenges include part shrinkage, warpage, and sink marks. Addressing these issues involves optimizing the mold design, adjusting processing parameters, and incorporating design features like ribs and fillets to improve part stiffness and minimize shrinkage.
Can you describe a project where you successfully optimize the design of a plastic component to reduce manufacturing costs?
Certainly. In one project, I redesigned a plastic housing for a consumer electronics device by simplifying the geometry and consolidating multiple parts into a single injection molded component. This not only reduced material usage but also minimized assembly time and tooling costs, resulting in significant cost savings for the client.
What software do you use for sheet metal design?
I am proficient in CAD software like SolidWorks, AutoCAD, or CATIA for creating detailed sheet metal designs.
Can you explain the difference between bend allowance and bend deduction?
Bend allowance is the amount of material consumed by the bend, while bend deduction is the amount subtracted from the total flat length to calculate the flat pattern.
How do you determine the bend radius for a specific material and thickness?
The bend radius is typically determined based on the material's thickness, with a general rule being to use a radius equal to the material thickness to avoid cracking or deformation.
What are some common methods for joining sheet metal parts?
Common methods include welding, riveting, adhesive bonding, and using mechanical fasteners such as screws or bolts.
How do you ensure manufacturability and cost-effectiveness in sheet metal designs?
I focus on designing parts with minimal complexity, optimizing for standard tooling and manufacturing processes, and considering material utilization to reduce waste and cost.
What factors do you consider when selecting a material for a sheet metal component?
I consider factors such as mechanical properties, corrosion resistance, formability, cost, and the specific requirements of the application.
How do you handle tolerance and fit considerations in sheet metal design?
I design parts with appropriate tolerances to ensure proper fit and function, considering factors such as assembly requirements, material variations, and manufacturing capabilities.
Can you explain the concept of nesting in sheet metal fabrication?
Nesting involves arranging multiple parts on a sheet of metal to optimize material usage and minimize waste during the cutting process, often done using specialized software.
What are some common challenges you've faced in sheet metal design projects, and how did you overcome them?
Common challenges include achieving tight tolerances, dealing with springback during bending, and optimizing designs for manufacturability. I overcome these challenges through iterative design refinement, collaboration with manufacturing teams, and leveraging simulation tools to predict and mitigate potential issues.
Can you walk me through your approach to designing a complex sheet metal assembly?
I start by understanding the functional requirements and constraints, then create detailed sketches and 3D models to visualize the assembly. I iteratively refine the design, considering factors such as ease of assembly, manufacturability, and cost effectiveness, and validate the design through prototyping and simulation before finalizing it for production.
Tell me about yourself.
I am a passionate mechanical engineer with 5 years of experience in design engineering. I have a strong background in computer-aided design and engineering analysis, and I'm excited about the opportunity to bring my expertise to your team.
What interests you about this position?
I'm drawn to this position because it offers the chance to work on CAD and finite element analysis, which align perfectly with my skills and interests. I am eager to contribute my expertise and continue learning in this dynamic environment.
Can you describe a challenging project you've worked on and how you overcame obstacles?
Previous role, I was tasked with designing and optimization of housings which presented several challenges, including weight, material corrosion and manufacturing constraints. To overcome these challenges, I used surface modeling, simulation study and lab testing to validate the product developed. Ultimately, we successfully completed the project with the product passing all the stages of product development.
Good morning, thank you for coming in today. Let's start with a brief introduction. Could you please tell me about your experience in surface modeling?
Good morning, thank you for having me. Certainly, I have 7 years of experience in surface modeling, primarily using tools like CATIA V5 and IceSurf. During this time, I've worked on various projects, including automotive and aerospace designs, focusing on creating class A surfaces to meet aesthetic and functional requirements.
Impressive. In your opinion, what are the key differences between class A surface modeling and other types of surface modeling?
Class A surface modeling is all about achieving the highest level of surface quality, ensuring that the surfaces are free from any imperfections or discontinuities. It requires meticulous attention to detail, as even the slightest deviation can affect the overall appearance and aerodynamics of the product. Unlike other types of surface modeling, class A surfaces must meet strict criteria for curvature continuity, tangency, and curvature consistency.
How do you ensure the quality and precision of class A surfaces in your work?
I employ a combination of advanced modeling techniques and industry best practices to ensure the quality and precision of Class A surfaces. This includes using curvature analysis tools to evaluate surface quality, creating surface continuity across different parts of the model, and refining surfaces through iterative processes until they meet the desired specifications. Additionally, I collaborate closely with design engineers and stakeholders to incorporate feedback and make necessary adjustments throughout the modeling process.
Can you walk me through a challenging project you've worked on involving class A surface modeling?
Certainly. One of the most challenging projects I've worked on was designing the exterior body panels for a high-performance sports car. The client had very specific requirements for the surface finish, including tight curvature tolerances and seamless transitions between different panels. I had to overcome numerous design constraints while ensuring that the surfaces not only looked visually appealing but also met aerodynamic performance targets. It required a combination of technical expertise, creativity, and problem-solving skills to deliver a final product that exceeded the client's expectations.
You stay updated with the latest advancements and techniques in class A surface modeling.
I make it a priority to stay updated with the latest advancements and techniques in class A surface modeling by attending industry conferences, participating in online forums and communities, and regularly seeking out training opportunities. Additionally, I am constantly experimenting with new tools and workflows to improve efficiency and quality in my work.
Thank you for sharing your insights and experiences. Before we conclude, do you have any questions for me?
Yes, I'm curious to know how the company approaches surface modeling projects and if there are any specific tools or methodologies that are favored here.
Great question. We place a strong emphasis on utilizing cutting-edge tools and methodologies to achieve the highest level of surface quality and precision in our projects. Our team is proficient in various software packages, including CATIA V5 and iSemSef, and we prioritize collaboration and innovation to deliver exceptional results for our clients.
Thank you for the information. I appreciate the opportunity to learn more about the company's approach.
What is mechatronics, and how does it apply to engineering?
Mechatronics is a multidisciplinary field combining electrical, mechanical, and software engineering. It involves designing and developing intelligent systems with enhanced functionality and performance.
Describe your experience with microcontrollers and programming languages.
I have worked with various microcontrollers like Arduino, STM32, and PIC, and programming languages such as C, C++, and Python. I've developed projects involving sensor integration, motor control, and data acquisition.
How do you approach system design and development?
I follow a structured approach, considering requirements, design, implementation, testing, and iteration. I ensure modularity, scalability, and reliability in my designs.
What is your understanding of control systems and feedback loops?
Control systems manage and regulate physical parameters. Feedback loops enable real-time monitoring and adjustment, ensuring stability and precision.
Can you explain the concept of signal processing and filtering?
Signal processing involves analyzing and modifying signals to extract useful information. Filtering techniques, such as low-pass, high-pass, and band-pass filters, help remove noise and interference.
Describe your experience with sensors and actuators.
I've worked with various sensors, temperature, pressure, light, and actuators, motors, solenoids, valves, understanding their characteristics, calibration, and integration.
How do you troubleshoot and debug mechatronic systems?
I use a systematic approach, identifying and isolating issues, analyzing data, and applying problem-solving techniques to resolve faults and optimize performance.
Can you discuss your experience with computer-aided design, CAD, and simulation tools?
I've used CAD software, SolidWorks, Autodesk, for design and simulation tools, Simulink, MATLAB, for modeling and testing mechatronic systems.
How do you ensure safety and reliability in mechatronic designs?
I follow safety standards, conduct risk assessments, and implement redundancy, error detection, and fail-safe mechanisms to ensure reliable and fault-tolerant systems.
What experience do you have with CAD software and design tools?
I have worked with CATIA, SolidWorks, and Autodesk Inventor, and have expertise in designing and developing automotive components and systems.
How do you ensure compliance with automotive design standards and regulations?
I stay up to date with industry standards and regulations, such as ASME and SAE, and incorporate them into my design process.
Describe your experience with finite element analysis, FEA, and simulation tools.
I have used FEA tools like ANSYS and NASTRAN to analyze and optimize designs for structural integrity, stress, and vibration.
How do you approach design for manufacturability, DFM, and assembly?
I consider production processes, material selection, and assembly methods during the design phase to ensure efficient and cost-effective manufacturing.
What is your understanding of automotive engineering principles and vehicle dynamics?
I have a strong foundation in vehicle dynamics, kinematics, and kinetics, and apply this knowledge to design and develop automotive systems and components.
Can you discuss your experience with design optimization techniques and topology optimization?
I have used optimization tools to minimize weight, maximize performance, and improve safety in automotive designs.
How do you collaborate with cross-functional teams, including manufacturing and testing?
I effectively communicate design intent, participate in design reviews, and work closely with teams to ensure successful design implementation.
Describe your experience with automotive-specific design tools and software.
I have worked with tools like Siemens NX, PTC Creo, and CATIA V6, and have expertise in designing automotive components, such as engines, transmissions, and suspension systems.
Can you walk us through your design process for a recent automotive project?
I follow a structured approach, starting with requirements gathering, concept development, detailed design, analysis, testing, and iteration.
How do you stay current with industry trends, technologies, and innovations in automotive engineering?
I attend conferences, participate in webinars, and engage with online forums and publications to stay up to date with the latest developments and advancements.
What experience do you have with HVAC system design and analysis?
I have worked on designing and analyzing HVAC systems, including ductwork, piping, and equipment selection, using tools like AutoCAD and Revit.
How do you ensure compliance with ASHRAE standards and local building codes?
I stay up to date with ASHRAE standards and local building codes, and incorporate them into my design process to ensure efficient and safe HVAC systems.
Describe your experience with heat transfer and fluid dynamics in HVAC systems.
I have a strong understanding of heat transfer, fluid dynamics, and thermodynamics, and apply this knowledge to design and optimize HVAC systems.
What is your approach to designing energy-efficient HVAC systems?
I consider factors like insulation, airtightness, and renewable energy sources, and use tools like energy modeling software to optimize system performance.
Can you discuss your experience with CAD software and drafting standards for HVAC systems?
I have worked with CAD software like AutoCAD, Revit, and SolidWorks, and have expertise in creating detailed drawings and models for HVAC systems.
How do you select and size HVAC equipment, such as fans, pumps, and coils?
I use manufacturer data, industry standards, and calculation tools to select and size equipment for optimal system performance.
Describe your experience with control systems and building automation systems BA integration.
I have worked with control systems and bus integration, including programming and commissioning, to optimize HVAC system performance and energy efficiency.
Can you walk us through your design process for a recent HVAC project?
I follow a structured approach, starting with load calculations, system selection, detailed design, and analysis, and iteration based on performance data.
How do you collaborate with cross-functional teams, including architects and contractors?
I effectively communicate design intent, participate in design reviews, and work closely with teams to ensure successful design implementation.
What is your understanding of indoor air quality (IAQ) and humidity control in HVAC systems?
I design HVAC systems to maintain optimal IAQ and humidity levels, using strategies like air filtration, ventilation, and dehumidification.
What is tolerance stack-up analysis?
Tolerance stack-up analysis is a method to calculate the cumulative effect of tolerances on the dimensions of a part or assembly, ensuring that the design meets requirements and functions as intended.
How do you perform a tolerance stack-up analysis?
I follow these steps: define the problem, identify tolerances, determine the tolerance stack-up equation, calculate the total tolerance stack-up, and interpret results.
What are the different types of tolerances?
There are linear tolerances, e.g., length, width, angular tolerances, e.g., parallelism, perpendicularity, and concentricity tolerances, e.g., roundness, cylindricity.
How do you calculate the total tolerance stack-up?
I use formulas like the root sum square, RSS, method or the worst case method, depending on the analysis type.
What is the difference between worst case and statistical approaches?
Worst case assumes all tolerances are at their maximum limits, while statistical, RSS, considers the probability of tolerances occurring simultaneously.
How do you determine sensitivity to tolerance variations?
I analyze the contribution of each tolerance to the total stack-up, identifying critical tolerances that impact design performance.
How do you use tolerance stack-up analysis to optimize design performance?
I use the results to identify areas for tolerance tightening or relaxation, ensuring design requirements are met while minimizing manufacturing costs.
What software tools have you used?
I have used tools like Excel, MATLAB, and specialized tolerance analysis software.
How do you communicate results?
I present clear, concise reports highlighting key findings, recommendations, and design improvements to stakeholders.
What experience do you have with CFD software like ANSYS Fluent, OpenFOAM, or COMSOL?
I have worked with ANSYS Fluent and OpenFOAM to simulate and analyze fluid flow, heat transfer, and mass transport in various industries.
How do you validate CFD results with experimental data or analytical solutions?
I compare CFD results with experimental data or analytical solutions to ensure accuracy and validate assumptions.
Describe your experience with mesh generation and grid independence studies.
I have generated meshes for complex geometries and performed grid independence studies to ensure accurate and convergent solutions.
What is your understanding of turbulence models and their applications?
I have worked with various turbulence models, including RANS, LES, and DNS, and understand their strengths and limitations.
Can you discuss your experience with multiphase flow simulations and interface tracking methods?
I have simulated multiphase flows using VOF, Eulerian, and Lagrangian methods, and understand the challenges of interface tracking.
How do you optimize CFD models for computational efficiency and scalability?
I use techniques like mesh refinement, model reduction, and parallel processing to optimize CFD models for computational efficiency.
Describe your experience with CFD post-processing and visualization tools.
I have used tools like ParaView, TechPlot, and Ansys Insight to visualize and analyze CFD results, including flow fields, pressure contours, and temperature distributions.
Can you walk us through your CFD workflow for a recent project?
I follow a structured approach, starting with problem definition, mesh generation, simulation setup, solution, and post-processing, iterating based on results and design requirements.
How do you stay current with advancements in CFD methodologies, software, and hardware?
I attend conferences, participate in webinars, and engage with online forums and publications to stay up to date with the latest developments and innovations.
What experience do you have with piping design software like AutoCAD, CADWorks, or PDMS?
I have worked with AutoCAD and CADWorks to design and develop piping systems, including layout, routing, and stress analysis.
How do you ensure compliance with piping codes and standards like ASME B31.3 or B31.1?
I stay up to date with industry codes and standards, and incorporate them into my design process to ensure safe and efficient piping systems.
Describe your experience with piping materials, fittings, and valves.
I have knowledge of various piping materials, fittings, and valves, and select them based on application, pressure, temperature, and corrosion considerations.
What is your approach to designing piping systems for stress analysis and flexibility?
I use software tools to analyze piping stress, flexibility, and support requirements, ensuring safe and efficient system operation.
Can you discuss your experience with piping layout and routing for plant and offshore facilities?
I have designed piping systems for various industries, considering factors like space constraints, accessibility, and maintenance requirements.
How do you collaborate with cross-functional teams, including process and mechanical engineers?
I work closely with teams to ensure piping designs meet process requirements, mechanical integrity, and safety standards.
Describe your experience with piping specifications, standards, and documentation.
I develop and maintain piping specifications, standards, and documentation, ensuring consistency and compliance with industry standards.
Can you walk us through your design process for a recent piping project?
I follow a structured approach, starting with process requirements, piping layout, stress analysis, and documentation, iterating based on feedback and design optimization.
How do you stay current with industry trends, technologies, and innovations in piping design?
I attend conferences, participate in webinars, and engage with online forums and publications to stay up to date with the latest developments and advancements.